Hello, and welcome to my session about ephemeral environments. Now, who am I? My name is Tom Robert. I have about 8 years experience in Drupal. I'm a consultant for IAMRoot, and I'm currently working for Capgemini and Lampiris Total. So, ephemeral environments. I can hear you thinking, what are environments? Well, ephemeral, it really means fleeting, lasting for a very short time or momentarily. So you can think about this as a sandcastle that gets washed away with the sea. That's what I want to accomplish with environments. I want to spin up an environment that is only used for one purpose and then deleted immediately after. Now, why would I want this? Well, I have some use cases in mind. For instance, a client, he wants to change a color on the website. You have got ongoing development on your staging server, and you don't want to show all your changes on your local machine, so it would be easy just to create a small POC environment just to showcase to the client so he can look at it at a public website on his own time. A use case two, it's when you are working with a big team on multiple projects on the same code base. So you want to test and showcase the features individually, but you don't want to hinder each other. So that's why you could spin up a feature environment for each project. And use case three is like your business is testing a release candidate. You want to run a full test suite, but you do not want to interfere with your business testing. So you create a test environment and then run all those expensive tests. Of course, there will be more use cases which we can use this. The stack I've been using is a GitLab Docker Kubernetes setup. Now, GitLab, well, for me it is one tool to rule them all. It has a Git repository, it has CI/CD pipelines, and it has a Docker registry. Now, it also has some extra functionalities, but yeah, not needed here. Docker, which is actually just a tool to create and manage software containers. And containers, there really are like isolated processes like in Nginx or a MySQL. And then Kubernetes, which is actually a container orchestration tool, which was designed by Google, and it allows configuration, deploying, and scaling of software containers. Now, this is a pretty high-level architecture of what I want to achieve. So a branch is created or updated. It triggers a GitLab-ci pipeline. It builds a Docker image, and then, because I don't want to deploy everything all the time, I have a manual action that will trigger a deploy on my Kubernetes cluster, and it would be easily accessible by the branch name .the project name .ephemeral.iamroot.io. For this, I have some prerequisites. You have to have a pre-production or a production website access. You need to have SSH access on it. And for demo purposes, I have installed a Drupal 8.6 umami profile on my VPS, which is available at umami.iamroot.io. I have, of course, a GitLab project, the umami project in GitLab. It has, for this test case, 3 branches. You have a master, a develop, and a feature pizza branch. And you need to have a Gitlab-ci runner enabled with Docker in Docker. Now, this is a bit tricky because you cannot really use the free shared runners from GitLab because they do not have Docker capabilities. So you would need to set it up, but GitLab provides an easy way to set this up on your Kubernetes cluster. So you have to read the documentation to set it up. Now, the lifeline during this talk is the Gitlab-ci file. In Gitlab-ci, we have defined 3 stages: a build, which I'm actually not using for this demo, a package, which I have named a Docker package, and a deploy, which is of course a Kubernetes deploy. So yeah, all this information is available on my my GitLab account, gitlab.com/imroot. The Docker package. So for Docker, we start from a base file. So it's actually an Nginx PHP container. And it comes with Nginx pre-configured, with PHP 7.2 pre-configured, and all the Drupal dependencies installed. It has Composer, it has Node, it has a Drush launcher, and it also contains all the deploy SSH keys. Now I'm using Supervisor because I'm running 2 processes in one container. This is not really aligned with the Docker philosophy, but it makes my life a little bit easier. Then the Docker file itself, so it is located in the repository. It starts from the base image. What it will do is then it will copy a tarball of this project that was created by the Gitlab-ci pipeline. It will copy the start.sh scripts, which is your Docker entry point. And for this, I'm still using wait for it to be sure that my MySQL container is up and running before actually starting my Nginx container. But this actually is a bit legacy because I started testing with Docker Swarm, and there it was needed. In Kubernetes, we should be able to use the Kubernetes lifecycle hooks to make this work. So how does this look in my gitlab-ci.yaml file? You can see I'm on the Docker package stage. I create a script, I create a tarball of my project. I authenticate to the GitLab registry with the predefined tokens. I build my Docker image, and after that I push it to the Docker registry from GitLab, and I tag it with the commit, with the feature name or the branch name together with the commit hash. So when you use ref slug, it actually means it's a cleaned name of your branch. For the Kubernetes deploy, Kubernetes stores all its configuration. The configuration for Kubernetes can be stored in YAML files. I'm using 4 YAML files, which are also in my repository. First one is the namespace. Now, I try to contain all, when I contain all my containers within a namespace, it makes it easier for the servers or the container to connect to each other. So I don't have to update the container names like Drupal and MySQL. They stay the same for all my branches. And all the access is contained within this namespace. Then I've got some default pvc.yaml, which is the persistent volume claims. It contains my MySQL and my Drupal files. I have a default MySQL.yaml, which actually is just a MariaDB deploy. And I have my Drupal.yaml file. Now I want to highlight 2 things in this Drupal.yaml file. One is ingress. And ingress, it is like a Kubernetes traffic router. You can compare it a little bit with traffic or an Nginx proxy. What this actually does is you define your host. In my default file, this is master.umami.ephemeral.imroot.io, and you connect this with a backend service, and ingress and Kubernetes will do all the rest. Will all do all the routing for you. And in the Kubernetes deploy, we just define the image that is used for Drupal as the one defined in your GitLab registry. So for the default, it is registry.gitlab.com/imroot/umami, and it takes the latest tag. How does this look in your GitLab-ci file? Well, I start from a basic Alpine image. I then install the kubectl command line tool. I configure the kubectl with the GitLab CI/CD variables, which is then actually the URL of your cluster, the username, and the password of your administrator for your Kubernetes cluster. After that, we replace the default namespace, which was master to start with the cleaned branch name. And we also replace the default registry image with the ones we have created and pushed to the Docker registry. So it is the one with the branch name and the commit hash. After that, we just apply this configuration to our cluster, and our code is deployed on our Kubernetes cluster. But of course, now the code is deployed. We want this site to be fully installed and fully available. So we install and configure it. We want to install and configure the Drupal ephemeral. What we started was, when we created our Docker image, we started with the start.sh entry point. This will run a composer install, which will install all the dev dependencies. And I've been using Pning to build my environment and to install this environment. Now, what is Pning? It's actually just a PHP build tool, and I've defined 2 stages in there: build dev, to compile a team if it's needed, or to run some custom build scripts. After that, I want to install it. So I'm using Pning drush extension to install Drupal, to create a writable folder, to sync the database from your pre-prod website, and also to sync the files from your pre-prod website. After that, I run my custom deploy scripts, which would then update the entity, update the database, import all the new configuration we have, and clear the cache. Now, drush sync files in DB. From drush 9, we are able to store all the aliases in our repository. So this is what it looks like in my repository. I have created a CI/CD user, which has SSH access to my production website. It has a read-only access, and this key, the private key for this, it is stored in my Docker base image. So I'm always using the same user for to go to my production website. Now, of course, this one is read-only on the machine, but when you have access to Drush, you have access to the complete SQL database. So it has a bit of a security issue. Because of this, I will remove the access that I have in my machine after the session, so you cannot access it. Now, to come full circle, our website is deployed. We did all our tests. We did what we needed to do on this ephemeral environment. Of course, now we just want to delete it and give up the resources back. So this is fairly easy because we're using a namespace. The only thing we need to do is delete the namespace. We can run a kubectl command from your machine, so kubectl delete namespace, and it's gone. We can use the web interface of your Kubernetes cluster, or we can create an extra API, an extra web interface which connects to your Kubernetes cluster's API. For this, I also have some improvements to be done because nothing is ever perfect. Composer install runs a lot if you're in a real project. You have your build, and maybe some other things that triggers your composer install. What I actually want to do is I want to use GitLab to create a GitLab artifact, which I then use in my Docker package instead of just using the core, just using the core files. So we can use 2 artifacts, one with the dev dependencies and one without. Wait for it, .sh was needed for Docker Swarm, but is not really useful in a Kubernetes. We could use the lifecycles hooks for this. At this point, when I redeploy a feature, the database is also newly installed and synced with the production website. Now, if we already have some database changes on an update, we don't want to destroy the database and we want to keep the database and the files. Like I mentioned before, using SSH keys, it has some security implementations. And kubectl command, it's not really easy to delete afterwards, so we can improve the deletion process after use. And more improvements can happen. All right. So let's see the magic happen. Now, originally I wanted to do a live demo, but it took 7 minutes and I only have a session for 25 minutes, so it would take a bit too long. So I made a video and speed up some things. Just to give you a big, small recap of what I'm trying to do, I want to create or update a branch. I'm triggering a GitLab-ci pipeline. I'm building my Docker image. On a custom action, I deploy it to the cloud with an easy, accessible URL. Now for my demo setup, I have my production website, which is umami.imroot.io. And in that one, I have created a demo root. Is this open? No. Oh, okay. So here I've created a demo root, which actually shows the updated feature branch name. It's called my awesome pod. I had to give it a name. And I created a video of what I'm doing. So here I'm checking out a new branch, creating a new branch. Changing the name for my awesome pod. Committing my code. And pushing it. The branch name I used here is feature/sushi, because we're in a food magazine context. You can see now the GitLab-ci pipeline is triggered. The Docker package is running. And this can take a while, so it would be also a good time to take a coffee when you're doing that at home. I sped it up a little bit. Job succeeded. Trigger it. Now I've been using a Google Cloud cluster for setting up my environments. So sure. You see this is the Google Cloud interface. You can see that our new ingress controller is created. Now I'm going into my container logs, which is installing, which it's running the composer install now. Doing the database install. Now it's not really updated in this picture, but when we go to the URL, we can see that everything is up and running, and the branch name has changed to feature/sushi. Okay. Now to delete the ephemeral, it goes a little bit faster. can still see it's up and running. One command. Has already disappeared from my interface, and the URL is still accessible, but yeah, it's going to the default backend. All right, so are there any questions about this? No questions? Actually, I haven't checked the cost. I only checked the technology. Yes. Oh. I think you can do first your Docker container image so that everything is up and running. You don't need to push everything in your GitLab-ci. So I think the main thing is learn how to GitLab-ci works, and then gradually implementing those things. So building a Docker image, and then pushing those Docker images to the cloud, to your cluster. That was more or less an answer. But yeah, the lifeline for the story is GitLab-ci. If you know how that works, it's fairly easy to puzzle all those things together. Right, no problem. If there are, yes. Mm-hmm. Yeah, when you first do, when you create a branch, you create a new machine. And one of my improvements I still have to do is not to trash the database or trash the files, so that it doesn't install again, but just checks on this cluster service, is my database available or not? If yes, do not do the install and do not do the sync with production. And then you can modify the database and keep it during your testing phase when you're doing updates. But still an improvement. All right, then, thank you very much.